Hello everyone, welcome to Maans Chandigarh IAS Academy. So myself Neeraj Nachiketa, faculty of Science and Technology and Environment. Now I've been teaching this subject for a long time and I have already given you certain introduction part of the syllabus and the pattern of the examination. And we have started with the developments in science and technology, indigenization of technology. And in that context, I have discussed important Indian scientists and their contributions. Now today in this session, we are going to discuss about development, right? Continuing with our topics of last class or last session, development in space technology. In space technology in India. And you know that we have already covered in the classroom about contribution made by various scientists, and I have mentioned the name of Dr. Vikram Ambalal Sarabhai, who is the father of India's space program. So that part we have already discussed in the previous session there. Let's going forward, we will discuss about what are the various development. Let's say you get a short question to write in the main examination. So what are the important points which you have to write? That I am going to cover here. So if you look at here, our legacy here. So first point is that our space program, like Indian space program, right? Spans over. So after independence, let's say after independence, 1947, and then 1950 onward, if you look at the developments in the past, from 1950s till now, right, it is a spanning more than 65 years of a development. And as you know that central government is celebrating the Amrit Kal, that is a Amrit Mahotsav, 75 years of India's independence was celebrated, and now recently you know that our Republic Day, that is being now celebrated there. So given the fact about our plans spans over 6 decades, more than 6 decades. But I am writing as 6 decades because basically if you look at space technology development, that is from 1960s onward, real sense. Although 1950s onward, Indian government started the work with the development of science and technology, but if you look at in the real sense, our technological development and the way it progressed, that is from the 60s onward. So here, that's the 6 decades which I have given, right? With the establishment, you all know that today we are all proud of ISRO, Indian Space Research Organization, which is the scientific organization which does all the development in case of space technology, satellites, spacecrafts, launch vehicles, right, different applications of space technology. All this comes into that one. So ISRO in 1969, this is where our in a formal way things goes, but our space mission programs and the R&D, research and development, started in 1961 onward. But formally, if you look at scientific organization, ISRO, Indian Space Research Organization, that was formed in 1969. Now you know that later on here, Department of Space, DOS, Department of Space, DOS, right, was formed in 1972, was formed in 1972. ISRO and various organizations of ISRO works under DOS. You all know that in our country we have 2 departments, Department of Space, DOS, and Department of Atomic Energy, DAE. Both right after independence come within PMO, Prime Minister's Office. That is direct under the supervision of our Prime Minister. So that's where this comes here. So 1972, and ISRO as an organization work under DOS as a scientific organization to develop that. And you know the chairman of ISRO, right? Right now Dr. V. Satyanarayana is the chairman, right? Before that, Dr. K. Somnath was the chairman. and the first chairman was Dr. Vikram Sarabhai, the founding father of space program in India. So chairman of ISRO has been given equal rank of secretary to the Department of Space. He, as a scientist, not only in charge of all the activities of ISRO and the entire setup of the organization, but he also looks into the policy, program, budgeting, implementation, part of the Department of Space, right? DOS part of it. Now, another very important thing is that in our country, for development of certain important areas of science and technology, we have a commission. So, a very important body under this DOS is the Space Commission. Space Commission. Space Commission, right, under DOS, under Department of Space, right, helps in policy formulation, what India should develop in the coming time, policy formulation, budgeting of important space missions, where ISRO, what technologies need to be there, right, finalization of future space programs, then implementation of policies and programs, whatever space policies we have and the programs, it looks into that. So when you're writing answer, you need to bring about those kind of perspective. So what I mentioned here, that part you have to bring over. Now let's look at here. When you do the search here, when you go to the Google here, why I'm doing this search and taking you to this one? The reason is that when you come across such kind of a body, you should go and see that. Right? You should go and see that. Although you don't have to write in the answer, but you are aware of it. Now see here. So this Space Commission consists of members. Now first member, you know that, Dr. V. Narayanan. Right now he is the chairman of ISRO. So Secretary Department of Space. Then you know Dr. P.K. Mishra, Principal Secretary to the Prime Minister, PMO. Then comes Sri Ajit Doval, you know that. He's a National Security Advisor. Right. Then Dr. Sri T.V. Somanathan, Cabinet Secretary. Right, he's a member. Now you can see here Sri V. Volnam, that is Secretary Department of Expenditure. Then Sri Vikram Misri, Foreign Secretary, is a member. Professor Ajay Kumar Sood, Principal Scientific Advisor to Government of India, he's a member. Then Dr. Pawan Kumar Goenka, Chairman of InSpace. Now recently DOS and the central government has come out with a very good organization to promote indigenization of space technology in India with the participation of private companies coming to space program. That is called InSpace. InSpace, right? That provides a platform for startups, right? And bringing such kind of private players into the space domains and development of the market, what we call a space market in India. So that's what Mr. Pawan Kumar Goenka is the part chairman. Then you can see Sri Amardeep Singh Bhatia, he's secretary to DPIIT. Then Ms. Seema Jain, member finance, equivalent to Secretary of Government of India. Then Dr. K. Radhakrishnan, who retired as chairman of ISRO. He was earlier chairman of ISRO, chairman standing committee, IIT Council member. Then another great scientist, Sri A.S. Kiran Kumar. He was also as a chairman of the ISRO, but he retired, but is still working with Space Commission. His expertise, like a PRL Council chairman, member. Then coming to Professor Govindan Rangarajan, Director ISC, Indian Institute of Space Technology there, and Dr. Shankari Murli, Joint Secretary DOS Secretary. You can see here, so many people, they form this important body called Space Commission. So that today 21st century, where India stands right now. We can go much ahead and become one of the leading players. And we are there. We all are proud of ISRO. Chandrayaan mission, Mangalyaan mission. We are going for Gaganyaan mission, right? Aditya L1 mission. Today, ISRO, a long journey, right, has created that mark. And you all know that if you see the history of ISRO, from bullock cart, from bicycle, now we are into Mars. That's where our technology has developed. That's where India is standing today. We are within the top 5 space-faring countries in the world. And a lot of things are happening in the space domains. And now with the part of private players coming to space technology, that is going to change the entire landscape of space technology and applications in India. So that's what I mentioned here. This is where I mentioned that. Now what comes here? The next part, which I will discuss in the terms of developments. So if you have to develop, you have to see there, right, ISRO's, right, overall development. If you have to, bring about where the achievements are there, right, some of the achievements here. Later on in my session, I will go into more elaborate, more detailed manner, but today in this session, I'm just trying to bring about, if you have to sum up the ISRO's development, so I would like to bring into following categories to understand the development, and I will provide the achievements and the examples here. The first very thing we should be aware of, that is called launch vehicle technology there. Launch vehicles. Now in a common language, we call it as a rocket, space rocket. What is a launch vehicle? Launch vehicle is a space rocket which take spacecraft, satellite, crew module, or any kind of a component into the outer space. So in the development of launch vehicles technology, so if you look at the ISRO's thing here, the first thing is the historical development. Let's look at from a historical point of view. That was, that experimental, where we carried out, our experiments. So in this context, there are 2 important space rocket in the beginning we developed. And the story goes that, Dr. Vikram Sarabhai, father of space program, he went to Trivandrum, right? There's a village called Thumba. It's a very small hamlet, small village on the coastal area of Trivandrum, capital city of Kerala, Arabian Sea. So there is a church, Mary Magdalene Church. Dr. Sarabhai, right, met father, priest of the church, and requested to provide a place for our scientists to do research and develop the rocket technology. So the father of that church, Mary Magdalene Church, provided a cow shed, Goshala, a cow shed, where our scientists, that's bullock cart, we were bringing the components, with bicycle we were carrying the components there, right, developing that became our lab. And then first time 1963, sounding rocket, we tried with a very small rocket called sounding rocket. So that is the beginning, right? That is the beginning where it happened. The struggle, the hard work which brought that. During that time, Dr. APJ Abdul Kalam, the great Kalam, right? Although Dr. Kalam is known for missile technology in India, Prithvi, Agni, Nag and Trishul and Akash, but initially his career began with ISRO, and his role in sounding rocket technology was there, which later he was able to bring into the Agni missile technology. So here, historical, the first thing what we developed, SLV, satellite launch vehicle technology, and then later on we had ASLV, augmented satellite launch vehicle. So first thing is that satellite launch vehicle, a small rocket, we can go up to the sky in the 60 kilometer, that launch vehicle was developed. See, always the first attempt has been met with failure. but we never gave up. We went ahead and again did the testing. So SLV3 was the successful one. 1980 is there. And this was augmented, where first time strap-on, what is called strap-on motors, a small boosters were augmented to carry heavier payload. So augmented satellite launch vehicle. They were all experimental rocket here. They were only for testing purpose. Right? That was our beginning era. But at the same time, what I said, sounding rocket. But sounding rocket technology we are using even today also. Today also India is using that. Now comes our operational, commercial, which we are using right now. Operational one, right? Commercial one. So in commercial one, what do you know that we have got later sessions I will go in more detailed part. The first thing is the PSLV, Polar Satellite Launch Vehicle. Then GSLV, Geosynchronous Satellite Launch Vehicle. And now recently ISRO has developed a very important rocket called SSLV, Small Satellite Launch Vehicle. Our versatile satellite launch vehicle, rocket, Polar Satellite Launch Vehicle, PSLV. Most reliable workhorse of ISRO. That we have developed there. And then powerful rocket to carry more heavier communication satellite to geosynchronous satellite and those orbit there, GTO, geosynchronous transfer orbit to geostationary orbit for communication satellite, GSLV, geosynchronous satellite launch vehicle. I am going to discuss all this in detail. Today I am just giving you an overview of our development, but later on we will cover in a more entirety, more detailed part of it. So GSLV, and today we are using Mark II and Mark III. Although we developed Mark I, Mark II, Mark III. And you know what is very important thing about GSLV rocket? The last stage, third stage, cryogenic engine, which we use liquefied hydrogen with liquid oxygen. And now SSLV, Small Satellite Launch Vehicle. In order to meet the demand of launching smaller satellites, right, up to 5 kg, 10 kg, ISRO went to develop SSLV, right? And this is another very important development which I am right now referring that. And now coming to here, another thing here, future. Here where India is going in the launch vehicles, our future program. So in future, we are now working to develop first important thing that is called RLV, reusable launch vehicle. What does RLV stands for? Reusable launch vehicle. We are almost to the advanced stage of our own indigenous RLV. If you look at government agencies, NASA, USA, they had the technology. Russia, Roscosmos, they had technology. In China, right, they had a technology. So now India will become the 4th country in the world to have this RLV technology. We are into final phase, reusable launch vehicle. You know that human space flight, what we are planning for future, and in the future to build space station, RLV will be very, very important. Very recently, Pushpak landing experiment has been carried out. 3 times successfully, we have used that aircraft to land on the runway. So we are almost ready with the technology. Now comes here what? Another one which we are working, NGLV. Right? We are working for NGLV, which will be very, very advanced rocket. Right? Almost can carry 3 times more payload than GSLV Mark III, what we call LVM3. This here, LVM3, GSLV, and if you look at Mark III in this context, LVM3, Launch Vehicle Mark III, right, which we are going to use for Gaganyaan mission, human space flight, Launch Vehicle Mark III. Now it will be 2.5 times bigger in terms of the weight of the rocket. That will be NGLV, Next Generation Launch Vehicle, and can carry 3 times more heavier satellites and payloads. See, if you look at Mark III, LVM3 can go up to maximum 4 ton or 4,000 kg into GTO, geosynchronous transfer orbit. But here it will go up to 10,000 kilogram NGLV. And then for another very important technology we are working, that is called scramjet. Ramjet and scramjet. What is scramjet technology? Supersonic combustion ramjet. Now, whenever the word ramjet comes, ramjet is a kind of a engine which use atmospheric air as oxidizer to burn the fuel and provide propulsion. So, scramjet, supersonic combustion ramjet, provide hypersonic speed. So they are called air breathing. They use oxygen from atmosphere to burn the technology. And it will be another very important thing for our RLV program and other launch vehicle program. We can minimize our cost during the initial phase of the launch vehicle of the rocket, where we use the oxidizer. So initially when the rocket is lift off, so we can use scramjet to minimize that oxidizer, and also it will reduce our payload, this weight of the rocket, and we can carry more heavier payload. Again, this is a game changer. So now another, if you look at review, is a spacecraft, satellites. Satellites and spacecrafts developed by ISRO, right? So this overview is a skeleton, and then we will go through everything in a very detailed manner. So now satellites, if you look at, so I will divide here. First thing is the INSAT and GSAT series. And you know that main exam, it asks you question to write about development of space technology. So there you can write there this. So INSAT, GSAT, we'll go into detail part, is a multi-purpose. Is a multi-purpose satellite system, right? Indian satellite system, right? And now we call GSAT, geostationary satellite system there. So you know that communication, right? Mobile communication. Then you know that broadcasting, TV broadcasting, DTH, direct to home, TV and radio broadcast. Then what comes here? Apart from communication and broadcasting, we are also using for meteorological purpose, weather forecast, cyclone, earthquake, cloud, rainfall, meteorological purpose there. Then apart from that, we are also using for tele-education, distance learning, telemedicine, providing healthcare support. Then again, early warning system, early warning, that is a disaster management communication. Right, weather forecast, warning, all this, we are using this system here. We have one of the largest constellation of such kind of satellite. Now comes here IRS, Indian this remote sensing satellite system. IRS, remote sensing, Earth observation. Here, this is the Earth observation satellite. So, Earth observation. And you know that one of the very important application comes here, GIS, Geographical Information System. So, where we are using here, survey of resources, survey and management of resources, natural resources, bioresources like forest, wildlife, natural resources for water, soil, right? Then minerals, different metallurgical, in terms of that, what we look for, iron oxide and all, bauxite, hematite, vanadite, minerals, exploration there. Then again, what comes very important, cartography, mapping, the mapping purpose, hazard map, disaster management, earthquake zonation, earthquake prone area, cyclone map, landslide map, right? All those vulnerable areas can be mapped using the system of remote sensing satellites like ResourceSat, Cartosat, right? We have RISE-SAT, radar imaging satellite. Even security purpose, we can use Earth observation satellite there, right? Governance purpose, we can have agriculture mapping, forest mapping, wetlands mapping, environmental studies. So again multi-purpose, right? Again, it is a multi-purpose kind of thing there, along with meteorological application, even from forest, wildlife, right? Movement of animals, radio collar, geotagging, we can locate through that one. So all this application what comes through IRS system, right? Now you know that India has been state first developing a own GPS system, which you all know, IRNSS, Indian Regional Navigation Satellite System, or NAVIC, or what we call as a NAVIC system there. So we are now into development of another very important system, what is called here NAVIC, IRNSS, Indian Regional Navigation Satellite System, what we call as a NAVIC, navigation with Indian constellation, right? And 2013 we started with the program. So we have already launched number of satellites. We are now expanding the network. So first we have regional coverage of India and 1500 kilometers from the border, but now we are expanding more into that. It is our GPS, Global Positioning System, but regional. What is there? Regional. But if you look at worldwide, America's GPS, Russia's GLONASS, then China's Baidu, Europe's Galileo, they are total coverage of the earth, global. But we have built regional, Indian Regional Navigation Satellite System. But yes, we are expanding it. From regional, one day we'll also go for global. So here, and then for Airports Authority of India, for our civil aviation sector, we have developed Gagan, GPS aided geo-augmented navigation satellite system. Where are we using this Gagan system? Gagan system provide better signal to aircrafts, aeroplane in the sky, and basically help in air traffic control management in airports throughout the country. Again, that signaling part for the pilot, even bad weather condition or any kind of kind of a condition where the signaling problem happens, that gets reduced by Gagan, GPS aided geo augmented navigation satellite system. So ISRO and Airport Authority of India, for airports in India, this has been developed. Safety is a very, very important thing in terms of signaling. And you know that now air travel is increasing in India, like more airports have come up. Now there are some busiest airports in India, like Mumbai, Delhi, Chennai, and all this. So we can have those kind of Gagan system there, and which can help manage the traffic, air traffic, landing, takeoff, the Gagan system. And IRNSS we are developing, which is our regional GPS, global positioning system. And this can be used for both civilian and military application. For civilian use also we can do IRNSS, and also military application, particularly for the military application. I will be discussing all this in detail manner, but now you are getting the overview here. Now, if you have to sum up our next achievement of ISRO, so you know that number of space missions, space programs, right? Space missions, and this all key point you can use in your answer writing part. So what are the space missions, right? What we have completed successfully and what we are planning for future. So you know the lunar mission, study of Earth's moon, right? Lunar missions, and you all know that Chandrayaan 1, (2008) we launched, then Chandrayaan 2, like 2019, and then India created a history with a soft landing on the south pole of the moon, Chandrayaan 3, 23rd August 2023. That's what we are now celebrating every year, National Space Day, remembering Chandrayaan 3 rover. What is something here, that Vikram lander and Pragyan rover. Chandrayaan 2, we tried with soft landing, but we failed with the landing part. But Chandrayaan 3, we successfully landed it. And you know that the place where Chandrayaan 3 Vikram lander with the Pragyan rover was landed in the south pole of the moon, we have named that spot as Shiva Shakti. And where we had a failure, crash landing of the Chandrayaan 2, Chandrayaan 2, that crash landed. We were not able to have soft landing. That site has been named as a Tiranga. Chandrayaan 1 was only orbiter, but 2 and 3 we had two had an orbiter with lander rover, and third we had a propulsion with the landing rover. Now we are planning for Chandrayaan 4, which will also we are planning for future collect lunar sample, moon sample, come back to Earth. So this is one thing. Then interplanetary mission. Interplanetary mission, Earth and another planet. So in this context, interplanetary missions, we have already successfully carried out one landmark mission, which you know that Mangalyaan, Mars orbiter mission. Mangalyaan, that is a MOM, Mars orbiter mission. So red planet Mars. India is the first country in the world to successfully send a spacecraft, MOM, Mars orbiter mission, to orbit the Earth. That is called Mangalyaan. We are the first time in first attempt we did it. So that is one of the success story of ISRO. But now we are planning for Mangalyaan second. So 2014, now we are going for second Mangalyaan. And then now future, we are now planning for Shukrayaan. That means we will be sending a spacecraft to Venus, the twin planet of Earth, that is a Venus. What we see in the sky as an evening star and morning star, that Shukrayaan. That is our future program. This is a plan for it. All this, see, either in the mains exam you get to write 200 words, 150 words, 250 words, about development part of it, with examples, with dealing with current aspect. But second thing could be what? Question can be each one of them. Discuss Chandrayaan 3, discuss Mangalyaan, discuss Gaganyaan, discuss Aditya L1. Could be part of that. So we'll go in detailed manner. Third thing comes here, study of sun, solar mission. And you know that India is again a country which has gone to sun and studied that, and we are using Lagrange point 1. That is here what is called Suryayaan, Suryayaan, what is called Aditya L1, Lagrange point 1, L1. What is the Lagrange point? These are the points in the space, right, with respect to heavenly bodies, right, where the interplay of gravitational pull, attraction with centrifugal force, right, where these 5 points goes round, right. So there L1 between sun and the earth, if you take sun and the earth system, L1, Lagrange point 1, which is 15 lakh kilometers or 1.5 million kilometers away from the earth, where it goes around the sun. So we have already inserted Aditya L1 mission. 7 instruments as a payload, and we are studying the solar flares, coronal mass ejection, impact of solar flares on space weather, right? Study of corona of the sun, and all these things we have studied. I will be discussing that in more detail later on, but I mentioned here. Then you know that human space flight, right? Human space flight. You know that we are now going for Gaganyaan, and you already know that Gaganyatri, 4 Gaganyatris or Vyomnauts, Vyomnaut there. Mr. Subhanshu Shukla, right? Mr. Angad, Group Captain Angad Pratap, right? Group Captain Subhanshu Shukla. Then Group Captain, there comes Ajit Krishnan, and the 4th one, the Krishna Nair, right? So all this Nair, Krishnan, Pratap, and Shukla, they are the 4 Indian Air Force trained pilots which have been trained for becoming Indian astronauts. Out of that, Subhanshu Shukla, he went to the International Space Station, ISS, and stayed there. You know that current affairs, Axiom 4 mission. Axiom 4 mission, he went there, International Space Station, and then came back. So we are now planning for our first Gaganyaan, which will have a low Earth orbit. We'll use GSLV Mk3, Mark 3, LV-M3 rocket to put that crew module, a module where astronauts will be there, Indian astronauts, and will go around the Earth and come back, return back to the Earth. But our next Gaganyans, India is going to plan number of Gaganyans, will be able to build a space station, Bharti Antariksh Station, by 2035-36. So here this plays a very, very important role in future for that. Then our space station, right? That is Bharti Antariksh Station. This we have planned for 2035-36 time frame. Antariksha, just like a, will built in the low Earth orbit. Antariksha station, just like a, right? What you know that International Space Station, BSA. China is already building the Tiangong. That is a independently the space station there. Very recently, India and US, NASA and ISRO jointly developed a very important Earth observation satellite called NISAR, NASA ISRO Synthetic Aperture Radar, right? Polar orbit, north to south, for environmental purpose, disaster management purpose, ecological studies, and NISAR has been now launched, right? Is already working there. So NASA ISRO Synthetic Aperture Radar NISAR, which is doing the mapping, just like this one, just like a remote sensing satellite, Earth observation, is able to map polar ice, glaciers, and is able to find out the changes in the Earth's surface and even interior, plate movement, and can predict earthquake, landslides, even useful for disaster management, agriculture mapping, then meteorological studies, climate change impact, global warming impact on Earth, wildfire, melting of glaciers, all those things. NISAR, NASA ISRO Synthetic Aperture Radar. I will be discussing all those. I will be discussing every such area. So this is something called Jhalak Dikhla Ja, right? Is the Jhalak Dikhla Ja. So in a nutshell, when we say about development of India's space program, right, achievements of ISRO, this is the key points, the nutshell. But yes, in our next session, we will go in detailed manner. We are going to cover all these developments with its every dimensions, all aspects of that, which will be very, very important for all kinds of exams, whether it's a UPSC or state PCS or Punjab PCS, whatever. And this even topic help in prelims also there, prelims and mains exam. So we'll be studying about all these areas in a more greater detail. Till then, just read and revise, and we'll connect with the current affairs also there. Application, where the space application comes, how the relevance for common man, our security, our industries, our various applications. We'll see that. It's just tip of the iceberg, what I've shown here. Abhi picture baki hai dost. Right? So thank you all for watching this video, and remain connected with Maans Chandigarh IS Academy, and we will carry on our discussion in a greater detail, depth, understanding, and focus on PYQs, applications, current affairs, which will really help you, right, qualify the exam and also write very good answer and fetch good marks. Till then, take care of your health and stay blessed. Sabba khair. Jai Hind. Jai Bharat. Thank you.